Hi, and welcome to my video on E as a base in exponential and log functions. Recall the number E. The limit as n goes to infinity of bracket 1 plus 1 over n bracket raised to the n power is E. So let's do an illustration of these, and I'm going to put n as 100 into this. So let's go bracket 1, add on 1 division 100, and I'm going to raise it to the 100. And let's see what we'll get. And we'll get 2.7048138. So that's 1 plus 1 over 100 raised to the 100. So now let's go back, and beauty of this calculator, and go back and put 10,000 in, put 2 more zeros, bracket, and we'll raise it to, and I gotta have 4 zeros, 1, 0, 2 zeros, 3 zeros, 4 zeros, and see what. So what we did, we put 1 and 1 over 10,000 raised to the 10,000, and we got 2.718145.9. And we do the same again, 1 plus 1 over, and we do 6 zeros. 6 zeros is a million, and we raise it to the 6 zeros. And I can do that again, but if you try it yourself, you'll get 1782805. So if you read the books or read an article on this, you get 2.718281828 and 45, 90, 45, and it goes on and on and on because they're irrational. But the number E, which is represented by this limit, the E is 2.718281828, and again, I remember that it's going to be 2.7. So anytime you see an E, the base is roughly 2.7, or roughly a 3. That's how I equate with everything going okay. So again, E is a base, but it's approximately 2.7. 1828, 1828, 45, 90, 45. But I remember that it's 2.7. So let's have a look at graphing this E. So if the f of x, it says graph f of x and its inverse, state the domain and range of each. Well, this is the f of x. So the f of x, let's change the f of x to a y. So we get y equals e to the x. So this is x and this is y. So if we put x to be negative 2, then negative 1, 0, 1, and 2, what we have e to the negative 2. So I'm going to use my calculator and punch in e. Again, the number e has to be, and you will learn more about this later, the e, right here I got ex is in yellow, so I got to hit the yellow button first, and that gives me the e. So this is e to this power. So I'm going to put a negative 2 into that power. So e to the negative 2 is the same as taking 2.7, raising it to the negative 2. And it gives me 0.135. So I'm going to say 0.14 approximately. And again, to check, if you say it's 2.7 raised to the negative 2, you get close to the same. So keep in mind that E is approximately 2.7, roughly around a 3. And let's go back and put in, I'm going to put in -1. So I'm going to type that in again. So there's E. So now I'm going to do -1. So we hit enter and we get 0.36. I'm going to call it 0.37. And go back up and go over and we raise it. Well, if I raise it to the, let's raise it to the 0 power. Let's go back and take out that negative. So e to the 0 power, I don't even have to press the button. E to the 0 power should be a 1. Any number to the 0 power should be a 1 except 0. 0 to the 0 is undefined. So e to the 0 power, check it. It's a 1. Go back up and we put in a 1. If we put a 1 in, e to the 1 power should give me, again, it is 2.71828. So it's 2.71. And go back and raise it to the square or 2 power. We're going to square it and we should get 7.389, so 7.37. So we get 7.39. That's 5 or greater, 7.39. Now I'm going to graph that. We'll remove the calculator and graph that. So the graph is down here. So when x is -2 and y is, I'm going to take a very small little dot there. X is -1, a little bit higher. X is 0, y is 1. When x is 1, y is 2.7, so say close to 3. And x is 2, we get 7.3. So x is 2, we get 7.3, 7.4. So there's a 7 and almost a little halfway there. So it's almost like taking to the third, or when the base is 3. And there's the, notice that this base here is greater than 1, so it's a growth curve. Growth curve goes up to the right. Now, let's look at its inverse. So f to the x equals 3 to the x. So we change the f of x to a y, which is what we have here. But to do an inverse, it's the reflection in the line y equals x. So we're reflecting in this line. We're reflecting x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, and so on. X is 0, y is 0. So we're reflecting in this line. So that's the line y equals x. When you reflect in that line, the x becomes a y, and the y becomes the x. So x becomes y, y becomes x, because it's reflected in the line y equals x. Notice this is the inverse function. So we got y equals e to the x. This is x equals e to the y. So we got an x and a y. So what happens is, if you think about it, I have to take because y is an exponent, it's better to put the values of y into this equation here and work out what x is. So y is going to be -2, -1, 0, 1, 2. So that gives me 0.1, same as over here. So the table here is the same as this table, only they're switched around because of the reflection. Again, so, but this is with a base e, but we can also change this, this is an exponential form, and if I change it around like this, e, y equals x, then I can say, I'm going to put it in log form. So the log of the base is e, the exponent is y, the base is e, exponent is y, and the number is x. So we have, this is in the exponential form, this is in the log form. And since we have the y here now, to distinguish, we got to go f to the -1 of x is equal to log 2ex. So this is the exponential form of the base e. Now this is the log form of the base e. So if you take x and put 1.4 here, then with the base e you get the y value. But it's easier to think about this. Go back and look at this log form right here, like this, and you put the y in to get the x. If you try to put the x in here to get what the y is, then it's a little bit more work. So we have x to be 1.4, which is right here. So y is, okay, let me put a couple of these in that I don't have here. X is 1.4 right here. Y is -2. X is 3.7 right here. Y is -1. X is 1 right here. Y is 0. X is 2.7 roughly here. Y is 1. X is 5, and if I keep on going, I get a 7 there. So 7 is right here. 7.39, so let's say it's right here, and we get a 2. So there's this graph is reflected in the line y equals x. And again, notice the ordered pairs. This one is x is 0, y is 1. And this one, x is 1, y is 0. So the ordered pairs are changed around. And this one right here, x is 1, y is 2.7. And right here, this one is x is 2.7, y is 1. So they're reflected. The x and the y's are interchanged. And the domain of the exponential, the domain in this one, the domain of any exponential is always x belongs to the reals. The range is the y values, and the y values are greater than 0. And the asymptote a is y equals 0. Because this graph, which is exponential, the further you go to negative infinity, y approaches 0. So as x goes to negative infinity, y approaches 0. And in the logarithm, the base of a logarithm is reversed. So let's look at the domain is the range. Y belongs to the reals. The range is the domain. X is greater than 0. Remember, domain is always x and range is always y. And the asymptote is x equals 0. The asymptote for an exponential is a horizontal. The asymptote for a log is a vertical. So x equals 0. This number here. As this goes down and down and down, it's closer and closer to this asymptote, x equals 0. So we just wanted to look at the graph and do some graphs. Let's do some more. And do this one a little tiny bit quicker, but we don't worry about that. The f of x is a y, so you get y e to the x plus 2. So this is x and y. So we take our calculator and turn it on. So we get e, remember second function, ln. And we'll do more on this later as we go in the unit on ln, difference between log and ln. We'll explain that difference later. But right now, I'm just using this button to get this Texas Instrument don't have an E button by itself. A graphing calculator does. So this is e to the x. So we'll go. What we'll do. We'll put in again, x is -1, -2, -1, 0, 1, 2. So let's put in e to the -2. And plus, now we got to add 2 on. So that gives us 2.13. So let's go 2.1. And go back now. And go e to the -1. I put a negative in there. Let's go to there, delete that, and put in -1 bracket plus 2. Got to be careful. So z to the -1 plus 2. Notice this is the exponential, this is in a bracket. We're adding on 2, and we get 2.36. Let's say 2.4, approximately 2.4. And let's go back now and do it right this time. This time we delete that one and we put a 0 in its place. So e to the 0. E to the 0 is 1. 1 plus 2 is 3. That's C. Calculator says 3. So we have a 3. And we go back again and we put in a 1. So e to the 1. Remember, e to the 1. E is 2.7. So 2.7 plus 2 should give me 4.7. Makes sense? Remember, e is roughly 2.7. So e squared plus 2 is 9.38. Let's say 9.4. So the only difference is that the y has, move the calculator out, the y has 2 more than what it did before. So when x is -2, y is 2.1. When x is -1, y is 2.4. So just a little tiny bit higher. When x is 0, y is 3. X is 0, y is 3. When x is 1, y is 4.7. X is 1, there's 4. Let's say it's right there. When x is 2, we get a 9.4. X is 2, we get a 9.4. So 9, roughly 9.5. And we'll say it's about right there. Again, there's only approximation. There it is. But notice, it's always, this is an asymptote. The asymptote, this exponential, will never go any lower than 2. Because as x goes to -infinity, this goes to 0. So the asymptote is right here. That's the asymptote, y equals 2. So the graph goes along by that. So that means, if we look at it, the domain of an exponential is x belongs to the reals. The range is y is greater than 2. Y is always, again, it's greater because this is a plus. If this was a minus, this would be less than 2. And the asymptote, ASY, is y equals 2. Y equals this number right here. Again, there's, this is the asymptote. Okay. Now, let's look at its inverse. So f of x equals e to the x plus 2. So what we're doing is inverse. So the inverse of f of x is f to the -1. So we change the f of x to a y. Now we have to interchange the y with the x and the x with the y. Done. But I have to solve this. This is the inverse of x and y. So if I put the values, notice y is an exponent, so I have to put the values of y into this equation. To fill in the x first and look for the y would be a little bit more difficult. So it's better to fill in the y first because it's in the exponent. So y is -2, -1, 0, 1, 2. Or what we're doing is changing these, put them over here. So if I put a -2 in here, that's just going to give me the same as this one. So that's going to be a 2.1. Put a -1 in, I'm going to get 2.4. Put 0 in, put 0 in here, and I get a 3. Again, the table is reversed because we're reflecting in the line y equals x. And the line y equals x is right here. So it's reflecting in this line, y equals x. As you can, I won't say as you can see, the ordered pairs are switched. This is the line y equals x. So the reflection is that when x is 2.1, y is -2. Okay. when x is 2.1, y is negative 2, right here. When x is 2.4, y is negative 1. When x is 3, y is 0. When x is 4.7, let's say there's a 5, 4.7, x is 1. And again, we got to go to 9.5, we go on over. So let's say this is 9 here. So 9 gives me a 2. So the graph is doing this. And notice that it's tapering along. This is an asymptote now. So this asymptote right here is x equals 2. So it comes down and goes along by. Now, let's look at the domain, the range, and the asymptote. The domain here is, again, the domain is the range, so the range is y belongs to the reals. The range is the domain, so it's x is greater than 2, and the asymptote is x equals 2. So there's the asymptote. And what we're going to do now is take this equation and change it to a log form. So I'm going to take this equation and change it to a log form. Here we go. So we have, but I have to, this is e to the y, so I have to move the negative 2 to the left side to isolate the exponential. So now I have e to the y is x minus 2, so let's change it around. So log, base is e, exponent is y, and the number is x minus 2. So that's f to the negative 1 of x log x minus 2 base e. Remember, base e is roughly 2.7. Try not to get confused. So we have the domain of each of them. This is the domain for the f of domain, range, and asymptote for the f of x. This is f to the negative 1 of x. This is the inverse, the log. So this is this is an exponential. E to the x is exponential. This is a logarithm. The inverse of an exponential is a log. And again, think about it. You can't do the log of a negative number. So x minus 2 got to be greater than 0, which means x got to be greater than 2. You can't have 2. You can't do the log of 0. 2 won't fit. You can have a 3. 3 minus 2 is 1. You can have a 4. 4 minus 2 is 2. You can't have 2 because you can't do the log of 0. You can't have 1. 1 minus 2 is negative 1. You can't do the log of a negative number. So that's another way. When you get the log form, you let this expression here be greater than 0 and solve it, and that'll give you the domain, the numbers that you can work with. Okay, let's continue. Now I have one without graphing. It says the f of x equals a half log of negative x plus 1 to the base e minus 4. So this is the log form. Now I'm going to look for his inverse. So that's the f of x. So I change the y, f of x to a y. So I change the f of x to a y. To do its inverse is a reflection in the line y equals x. So y is x and x is y. And I'm doing this inverse. There's a unit in pre-calculus that I'm going to do. It's going to be on inverses of different types of functions. But now, since I'm in logs, since I'm doing the unit on exponential and logs, then I have to go and explain how to do the inverse, f to the negative 1. of this. So that's why I'm doing this question like this, to show you the inverse with how to do the inverse with log. Now, I have a change. I have it solved for y, but I can't get to the y because the y is the number with this log. So I have to solve the equation. So I can move the 4 over here, away from the log. So minus 4 goes to this side to become a plus 4. I have a 2, so I got to multiply by 2. So it's 2 times x is 2x, 2 times 4 is 8, 2 times a half is 1. So now what I've done, I've isolated. So I have the log, just rewriting it, log e, base e, negative y plus 1 equals 2x plus 8. So now, by removing the negative 4.5 to this side, adding on the net 4, multiplying by 2, now I got a base exponent number. So I have base exponent number. But I'm trying to solve for y. So e to the 2x plus 8 minus 1 equals negative y. I'm trying to get it, so I got to move the negative 1 over here. Sorry, move the plus 1 over here, make a minus. And now I got a negative, so that's the negative e to the 2x plus 8 plus 1 equals y. So just got to be careful. So this is the inverse. So the inverse is negative e to the 2x plus 8 plus 1. So the inverse of this logarithm is this exponential. And if you look at this one, this is a log. So negative x plus 2 is greater than 0. This number, this expression, got to be greater than 0. You can't do the log of 0 or a negative number. So we make this expression greater than 0. So that means that a negative x is greater than negative 1. Divide by negative 1, x is less than 1. When you divide an inequality by negative, it changes direction. So that's the domain. So right away, that's the domain. I can go right here and say the range is less than 1. The domain is the range. The range is the y value. So notice less than 1, this is domain, this is the range. In a log, the range is real numbers. So no matter what values of x I put in here, yes, the x value's got to be greater than 1. So the y values are reals. So that's in an exponential, we have x is reals. So in this exponential, I can take any value of x and put in here, and now I'll come up with a y value. So any value of x will work here, so x is reals. Again, the ranges belongs to the reals here in this log, so the exponential got in the exponential form, which is this form, they switch. So y is x, x is y. And the asymptote here, this is x is less than 1, so the asymptote is x equals 1. In a log, the asymptote is a vertical line. It can be x equals. And in an exponential, it's y equals. So if you're less than 1, y is less than 1 all the time, the asymptote is 1. Again, the asymptote in a log is x equals. The asymptote in exponential is y equals. So x is changed to y, y is changed to x. So I just wanted to do this solving here. And again, this is in pre-calculus, so this should be a great question to handle. But you got to do more work on this. I'm just showing you this type of problem right now. I got to do more work. And again, if you like my video, click on the like button. If you're not a subscriber and you wish to subscribe, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of a YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.